Hi everyone! I couldn't make it to class today because I'm attending a conference, so I decided to record my part of our presentation. Today, Alba, Christina, and I will be discussing bioremediation applications of the iron or Fe cycle, and the specific application that we'll be talking about is permeable reactive barriers, or PRBs. So here's some background information on PRBs and how they help to reduce contamination, migration in the subsurface. Contamination in the subsurface, which is the space beneath Earth's surface or the underground, is a major problem, especially in groundwater, since groundwater is a major source of drinking water, especially in arid environments like Arizona's. The goal for any contaminant is complete destruction, meaning to break down contaminants into completely harmless substances. But with many heavy metals, including uranium, arsenic, and other contaminants, complete destruction, unfortunately, is not possible. So the only feasible options for these certain contaminants and addressing them are containment, which is where you prevent a substance from spreading, and reduction is the other option, which chemically changes the contaminants into less toxic substances. Accomplishing these two objectives can prevent contamination from reaching areas where organisms, including humans, can be exposed, and therefore containing and reducing these contaminants helps to protect both public health and the environment. So one way of accomplishing these objectives and using the most viable solution that we have to date is to use what has been studied and implemented for a long time, permeable reactive barriers, which are used to intercept and treat groundwater using reactive media that reduces, absorbs, and precipitates contaminants. The most common reactive material in PRBs is zero-valent iron, which can serve as an electron donor in redox reactions, and thereby it provides microorganisms with the electrons that they need to metabolize environmental pollutants. And zero-valent iron can also be used to adsorb contaminants and thereby prevent the contaminants from moving through the subsurface, since these contaminants will attach or adsorb to the iron-containing materials, which typically have high surface areas, meaning that there's a lot of surface area for the contaminants to attach to and be removed from the flowing groundwater. And zero-valent iron, finally, can also be used to precipitate contaminants and remove them from the aqueous phase so that they do not move along with the groundwater as it flows in the subsurface. Here is a schematic of a PRB from Dr. Torres's presentation last week. Based on the direction of the groundwater flow from left to right, the treatment wall, or the permeable reactive barrier itself, can be placed where the contaminated area is the contaminated water is expected to migrate to, and the treatment wall can reduce, adsorb, and precipitate contaminants, leaving clean or cleaner water behind, which continues to flow in the subsurface. I'll hand off the rest of the presentation to Christina and Alba, and if you have any questions about my part of the presentation that you'd like to ask me, feel free to ask me them before or after the next class period on Wednesday.